Good morning viewers. In today's class, we'll be doing the mechanism for Freidal alkylation. Alkylation is the introduction of an alkyl group. The general term could be R, which could be a methyl, could be an ethyl, etc. I'm taking a special reaction where I'm converting a benzene into a toluene. By reacting it with a methyl chloride in the presence of a Lewis acid anhydrous AlCl3. The mechanism for this particular reaction would be your methyl chloride in the presence of the anhydrous AlCl3 cleaves heterolytically. Cl gets a negative charge, and since the AlCl3 is a Lewis acid and requires electrons, thereby the Cl minus is taken away by the anhydrous AlCl3, leading to AlCl4 negative. You are also left with a methyl carbocation, the electrophile. Hence, the first step would be generation of electrophile. The second step is the attack of the electrophile onto the benzene ring. This is your electrophile. Moving on to the benzene ring, the bond of the benzene ring, pi electron cloud, cleaves like this. This carbon gets a negative charge and therefore the methyl carbocation attacks there. Leading to, you get a methyl here, the H is already present, this carbon gets a positive charge. This carbon structure now goes into resonance where this carbon requires electrons, pulls the pi electron clouds towards itself. Hence, this situation remains the same, no changes here. This bond goes here, so this carbon will get a positive charge because it has given away the electrons. This would further go into resonance. This carbon requires electrons, it pulls the pi electrons towards itself. Hence, you end up into pi electrons here, a positive charge here. You have an H and a methyl. Moving to the last resonating structure. This carbon is in need of electrons, but there is no pi electron onto this carbon. So this bond breaks, the electrons are shifted to the benzene ring, leading to no changes here, no changes here. This bond is shifted in, no change in the methyl group. You are left with your H plus. So the H plus is replaced by the methyl when it attacks onto the benzene ring. Moving on to the step 3. Step 3 is the resultant of the two steps. In step 1, we used up the methyl in the attack onto the benzene. We are left with the AlCl4 from step 1 and the H plus from step 2. These two combine to give you the byproduct required, the HCl, and your AlCl3 was the catalyst in the reaction, so it is regenerated back, as you don't keep adding on the catalyst in the reaction. Once you've added, it is continuously regenerated in the process, so the reaction continues. Thank you.